we have left. I know that wasn't nearly enough time to do it. Don't worry about it. Again, it's not about the score. It's about having the answer. It prints all the right answers on your Scantron, right? So you have that. They're online also, but it's nice to have it right there in front of you on the Scantron. You're going to keep all that and study off of it. Let's do as many as we can in the next 45 minutes. And you could also look for the other classes. I'll go over it in the other class the next hour as well. So there'll be 2 of those on YouTube. If I don't get very far, we'll see. All right, so here we go. So how do you solve number 1? What do you do for logs? You count down the logs. Remember the steps I wrote out for logs? It's called the log countdown. So first, get the logs on the same side. So first get the logs on the same side. So I'm going to grab this log and jump it to the other side. So then I'll have log base 3 of x plus 2 minus log base 3 of x minus 3 equals 2. We good so far? Everybody with me? So you get the logs on the same side. Everybody getting theirs back? They all making it around? Scantrons? All right. So get them on the same side. So if you didn't do a Scantron, the answers are online, right? You can still get the answers online. Everybody know this document, everybody knows where that get a Scantron and have the answers before you. All right, so what do we do with the logs? We count them down. What do I mean? I mean it's going to go like this. It's going to go 2 logs. Next line's going to be 1 log, and then no logs. So I'm going to count down the logs. 2 logs, 1 log, no log. How do I make 2 logs into 1 log?
Log divided by log.
Yeah, remember the properties? Like subtraction becomes divide, adding becomes times, that whole thing. So this is subtraction. So, if this was adding in the middle, then I would multiply these guys like that, wouldn't I? If that was adding in the middle. But it's subtracting in the middle. So I'm going to divide them. Go back. It's going to be x plus 2 over x minus 3. Good so far? Subtracting becomes divide when 2 logs become 1 log. Remember the properties, right? Easier job for 2 logs, just subtraction. That's a simple operation. Dividing, harder operation for 1 log. Okay, 2 logs, 1 log. Next line, no log at all. What do I mean no log at all? I mean cross off the log. Lose the log. What happens when you lose a log? Base stays the base, other 2 switch. Remember, we've done that a million times? Whenever you lose a log, whoops, I'm scribbling all over the place here. Right over here. Whenever you lose a log, base stays, other 2 switch, right? So the 3 will stay, and then this and the 2 will switch. Instead of 3 to all that x stuff, it's 3 to the 2, and all that x stuff goes over there. Remember that? So we've gotten rid of the logs. We counted down the logs. 2 logs, 1 log, no log. So what do we do with that? Well, that's 9. 3 squared is 9, as you know, equals x plus 2 over x minus 3. Now you just put the 9 over 1 and cross multiply, huh? Solve for x. Can I go to a fresh screen? So this is number 1. 9 equals something. I don't remember what. X plus 2 over x minus 3. You guys okay? Everybody got that copy down? I go to a fresh screen. X plus 2 over x minus 3. Put that over 1. Diagonal, diagonal. So 9x minus 3 is 1. X plus 2. Boom, boom. Distribute 9x minus 27. Boom, boom. X plus 2. Okay, how do you solve for x? You got to get rid of one of them. So subtract x from both sides. So this is 8x minus 27 is 2. And then add the 27 to both sides. So 8x equals 29. And then last step, divide by 8, 29/8. Now, really you have to check. Remember, logs have to be checked. You have to make sure the inside of the logs is not 0, not negative. Remember that? So what I would do is, well, how do you do that? Is that hard? No. I would just divide that in your calculator real quick. 29 divided by 8, it's 3 point something. Who cares? Whatever it is. 3 point whatever. So go back. Look at the original here. Look with me. If you put a 3 point whatever in there, is that going to make that 0 or negative? 3 point something add 2 is 5 something. No, it's fine. How about right here? 3 point something take away 3. What is it? 3 point, whatever it is. 3 point something take away 3 is still going to be over 0, isn't it? So it doesn't make either one 0 or negative. It's good. It's a keeper. It's the right answer. 29/8. So which answer is that? D. There it is. Answer D. We good? Questions I can answer? Remember that? Okay. On to number 2 we go. Number 2, exponential. So it says e to the x plus 7 is 5. It's nice. All the answers have LNs in them, so you're probably going to be reminded, oh yeah, the LN thing. Which is kind of nice. Multiple choice helps out sometimes. Sometimes it's frustrating, like when it's E and stuff, but take the good with the bad, I guess. So LN on both sides on that, right? Because that's the letter in power, right? Hitler climbed into power, Stalin's in power. When the letter's in power, LN on both sides, and then the entire power thing drops down. It dethrones the power. Dethrones the power. Like that. Not good? And what's ln of E? 1. We good there? And then just move the 7 over. So it's ln 5, take away 7. Ln, is that not there?
Nope.
None of the above?
Mm-hmm.
Yep, it is. Slightly disturbing. But there it is. None of the above.
So much work for nothing.
Good on all that? All right, I'm going to move on. All right, so solve the exponential. Yeah, this one's harder for sure. So again, ln, minus 2, huh? Minus 2. Ln both sides, you see all the ln's, you'd be reminded. Ln, both sides. You know what happens? The powers drop down, the powers drop down. So we get x ln 3, x minus 2, ln 17. Yeah, really important that you put parentheses around that x minus 2 when you put it in the front like that. Does everybody see that? Why? Why is that so required? Well, think about this. If I write 5 minus 2 times 3, and I don't put parentheses, only the 2 is multiplying the 3, huh? Whereas if I put parentheses, then the whole 5 minus 2 is multiplying the 3. See the difference? And we want the whole x minus 2 multiplying. If you don't, this is what I see. I'm just saying the mistakes I see students make when I work with them, is they'll write it like that without the parentheses. That means only the 2 is multiplying the ln 17. That's not correct. The whole x minus 2 is in the power zone. Thus, the whole x minus 2 must come down and be a multiplier, not just the 2, right? So got to have those parentheses, absolutely essential. It's not just a style thing. All right, so then what? Well, then the ln 17 just distributes, right? When anything's up against parentheses, it distributes. So x ln 17 minus 2 ln 17, like that. We good to hear so far? Now, this is where a lot of people get stuck, right here. Let me help with this. This is something that's going to come up a lot in calculus. If you're going on to Math 5A, it's a very common issue, and that is x in 2 locations. What do? You need to know. You need to have a definite, clear battle plan when you have x in 2 spots. X in 2, forgot the x there. X in 2 spots. What do? Number 1, get the x's on the same side. Number 2, factor out x with a big parenthesis. Step 3, divide. So you need to have that in your 3x5 card or have it memorized. That's the plan. So you got to get the 2. See, there's 3 terms here, and 2 of them, here's the wall, 2 of them have x's, right? So first thing is you got to get those x's on the same side. So grab this term, subtract it, jump it over, whatever. X ln 3 minus x ln 17 equals, and then this guy just comes down, minus 2 ln 17. Good so far? So step 1, get the x's on the same side. All right, check. Step 2, factor out the x, meaning x and parentheses. ln 3 minus ln 17. See that? And now you can just divide, huh? Right? X wants to be alone, so divide by what's next to x. Boom, there we go. Hopefully that answer's there. Is it B? Minus 2 ln 17 over ln 3. Yeah, B. And it's B on number 3. Yep. Good there? Are we happy? You guys got that down? I move on to number 4. All right, I'm going to move on. This will be on YouTube if I'm going. Okay, so find the focus. X squared equals negative 16. So x squared is negative 16y, I mean. Negative 16y. So what should I do on this problem?
Get one side to the 0.
What should I do?
Like 16 equal to like minus 4.
Right, we got to do that. We will do that. What was I saying that you should always do on the parabola, hyperbola, ellipse problems? Draw a picture. No way you're going to, well, I mean, maybe, because you're picturing it in your head. I mean, one way or the other, you got to be looking at a picture, either on the paper or in your head. If you don't have something you're looking at, if you don't know, for example, which way this thing's going, up, down, right, or left, you'll just be guessing. I mean, because they all have a 4, right? If you don't know which way this thing's going, you're just going to be guessing, really. So everybody hearing me on that? I want to make sure I'm looking. This is the first one that alerted me in the other class. They were coming up to me and asking me how to do this, and they had no pictures. And they didn't realize you needed a picture. Because you think, well, it doesn't say graph, but you got it. Okay, so let's draw the picture first. So it's parabola, right? Parabola means only one branch. You guys with me? Because only one letter is squared. That's how you recognize that's a parabola equation. Because only one letter is squared. If y was also squared, it would be something else. One of those other two. But this one's only got one branch, right? It's a parabola. It's only got one U shape. It's either going up or down or right or left. So it's not the two branches that make the egg shape, which is ellipse. It's not the two branches turned away, which is hyperbola. It's only one branch. How do I know? It's only got one letter squared. One letter, second power, one letter, first power. So it's a parabola for sure, right? Okay. Now, how do you know which way it goes up? Most important thing on a parabola is up, down, right, or left. What tells you that?
The x squared means it either goes up or down.
That isn't the way I said it, even though you're coming to the right conclusion. Remember what I said? I thought I gave a beautiful way, a helpful way. Maybe just for me. Remember, it's what's unique about a parabola? What's different about a parabola? He has a first power letter. None of the other ones have a first power letter. So it makes sense that would be the special mark of the parabola, right? He has this. The other ones just have second powers everywhere. They don't have a first power. And that is what tells you the direction. Remember? I said the direction is told you by the first power letter. Right? What am I talking about? Well, this is positive y, positive x, negative x, as you know, on the axis, right? So what is this? Negative y to the first. This thing's going down. It's a negative y. Does that make sense? The first power letter tells you the direction. The first power letter, which is the unique characteristic of the parabola. The other ones don't have first power letters on that, right? So this one's going down. First power letter. So it's going down. So you want to have on your 3x5 card, all the different ones, like x squared is positive 4ay, and x squared is negative 4ay, right, that we went over before. And this one, y squared is positive 4ax, and then to the left, y squared is minus 4x. You want to have those four on your 3x5 card for sure. The hardest thing about a problem is knowing the direction. So you see minus y, you go, oh, it's this one, minus y to the first. Yeah, it's that one. So it's going down, okay? And not only that, I also need to factor out that 4, don't I? Parabolas, we always pull out the 4. We don't get a 0 on the right side. We don't get a 1 on the right side. That's the other equations, that we get the 1 on the right side. So we factor out a 4. 4 or negative 4. In this case, negative 4, huh? Negative 4 times what times y is the same as negative 16y? What number is a? 4. Right? That's the a. Everybody with me on that? Negative 4 times 4 is the same as negative 16, isn't it? Remember what we do for the parabola equations? You always factor out a 4 or negative 4. In this case, it's negative, so we factor out a negative 4 and then find out whatever comes next. That's a. And what is a? So what? A is 4. So what? Well, that's how far to the focus. A is 4. That's how far to the focus. From the center to the focus. Remember, A is the focus distance on the parabola equation. C is the focus distance on the other two. Remember that? Not so much? Maybe? So, all right, so 4. So what's the coordinates of this focal point then? It's over 0, down 4, isn't it? So there we go. It's B. That makes sense? Questions I can answer? We good on that? All comes from the picture and having these 4 different. Definitely. You must have these on your 3x5 card. Most important thing about a parabola is these 4 basic equations and the direction. Probably the most important thing in your 3x5 card is having those. Because the parabola is the hardest one because it can go 4 different directions. And if you get the direction wrong, everything's wrong. All right. I'll quit beating. Okay, number 5. Find the equation parabola again. Vertex at 1, 7. Focus at 1, 5. What am I going to do? I'm going to draw it, right? For sure going to draw it. Have you done that already? Let's draw it. So, over 1 up 7. 3, 5, 6, 7. And over 1 up 5. So the focus, there's the focus, and over 1 up 7, there's the vertex. Okay. So can you take that now and can you draw? Let me give you just a second if you haven't done it. I know I didn't give you hardly any time on this thing. Go ahead and draw real quick a parabola. Just from that picture. I hope you can tell whether it's going up, down, right, or left. Let me give you a second. And then from there, see if you can write the general equation. Give you just a second on that. Okay, can you tell which way it's going? Up, down, right, or left? It's got to be going down, huh? Is that good? Because they always hit the vertex, and the focus is always inside the satellite dish, so to speak, right? Like the receiver in the dish. Everybody see that? They always hit their vertex. Vertex means center. Vertex is another word for, well, on the parabola, it's another word for center. Vertex is the edges on an ellipse, huh? So they use those words kind of differently, huh? So is that good? It's going down because the focus is always inside the dish. So therefore, if it's going down, looking back, it's this one again. It's that basic equation. You want to have those 4 on your sheet for parabola, on your 3x5 card. So the general setup is x squared is minus 4ay. Good so far? But then we have to put the fact that the center is 1, 7. So that means x minus 1 squared, y minus 7. We good to there? Now, last thing, what is A? All we have left is to find the A. By the way, already we can eliminate, like, it's not answer A, it's not answer D, huh? And it's not answer C because that's positive. We know there's negative here. But careful, you could be B, but there's always that E. Do you see why? I'm not trying to be mean, but it is my job to make sure when I give you my stamp of approval that you really do understand this material. That means I have to eliminate random guessing because that will obscure whether you really know the material. Do you see why I have to put in E here? Because otherwise you could just guess at B without ever figuring out A, without figuring out what that A is. But this way you're required to find out if that A is really right or not. So how do we, because it could be option E, right? So how do we know what that A is? How do we figure out that little A? What's A? It's the focus point, huh? It's the jump from the center to the focus. That's what A is, how far from the center to the focus. That's what C is in the other two pictures, in the ellipses and the hyperbolas. It's the distance, which is what? How far from 7 to 5? 2. So A is 2. So this is minus 8, y minus 7. So the answer is indeed B. B is correct on that. Does that make sense? We good? Questions I can answer? On to 2 pages. All right, so they're giving me this equation, which is a parabola. And, okay, so looking at that, it's kind of backwards. I mean, it's, no, it's not. It's normal, yeah. So it's x plus 1 squared is y plus 2. Okay, so first thing you want to do is go back to your chart. What you have in your 3x5 card are the 4 directions of the parabola. So I'll go back to this. So I'm looking for x squared positive y. What's that? X squared positive y is right here, isn't it? But you want to, this most important thing in your 3x5 card is having these 4 pictures with their matching equations. See, it's right here. X squared is positive y. So that's what it looks like, and so we know that. So we know for sure it's going up because it's x squared is positive 4ay. So it's going up. So you can eliminate some of the answers right now, right? So you can eliminate, like, no way is it B, because they have that one going to the right. And no way is it D. If you look at D, D is also going to the right. So we're already down to just 2 options, A and C. Of course, none of the above also. A and C. So which one is it? Well, now we can do the center. What's the center of this shape? Remember, it's opposite, opposite, -1, -2. So the center is back 1, down 2, and the thing's going up. Isn't it? It's going up from back 1, down 2. That looks like option C. Everybody see that? Here, let me bring over. So there, see how option 2 looks like looks just like the picture I'm drawing? So option C looks right. The vertex is back 1, down 2. That's what they're saying. Now to be sure that it's not E, we're going to have to find the focus and the directrix. How do we find that? Well, the focus point is always whatever A is. It's A. What is A on this one? Am I losing you? I'm getting worried about time here. I'm just going to do this quick. I know this stuff's confusing. You're looking right here. You're saying, hey, look, this is supposed to have like a 4 and an A in the front. But it doesn't. It has nothing in the front. So what's that? Well, you tell me. What could A be so that 4 times it looks like nothing? And what is nothing? Nothing is really 1. There's really a 1 there, isn't there? You guys with me? You getting the hang of how we make things look different without being different? For the parabola, you've got to force a 4 to be there. You've got to. Without changing the overall outcome. So 4 times what is the same as 1? 4 times a fourth. right? You with me? Or 0.25 if you want to do decimal. 4 times 0.25 is 1. So it's like there's really a 4 times a fourth, or 4 times 0.25, quarter of a dollar, 0.25, right? Because that's 1, which is what we really have there. You guys okay with that? You always have to force a 4 on the parabola equation, no matter what is there. You got a million there. You got to force a 4. You got to force a 4. You got to factor out a 4. So there's really 4 times 0.25 there. So A is 0.25, which is how far from the center up to the focus. It's 0.25 up. And the directrix line is 0.25 back. Is that what C has? Absolutely. Because you see that focus is 0.25 up and the directrix is 0.25 down. Yeah, C is the right answer. We good on that? We'll move on. Is that okay? All right. All right, number 7, center focus, all that kind of stuff. Okay, so yeah, can we just do the center right away? Center's opposite, opposite, isn't it? Opposite, opposite. So -1, +2. So D's out. At least I can eliminate D. But it's A, B, or C. So we got this. So we better draw this thing. Drawing is always helpful. Back 1, up 2. So there's the center. Okay, now 36. This is where students were getting confused yesterday. I would write that as 6 squared and 3 squared. Just rewrite that for yourself to help. 36 is 6 squared. The 9 is 3 squared. And then just say, okay, so that's right and left 6. So from the center, I go right 6. So that'd be 1, 2, 3, 4, 5, 6. 2, 3, 4, 5, 6. That way. And 1, 2, 3, 4, 5, 6. So let's I go right 6, left 6, because that's what's under X. X is always right, left from the center. What's underneath Y, 3, is up 3, down 3, and then you draw your ellipse. Is that good like that? Everybody see how I did that? So back 1, up 2 is the center, right and left 6, up and down 3, because that's what's under X and Y. 6 squared, 3 squared. Make sure you rewrite 36 and 9 as 6 squared, 3 squared. That'll make it easier. Okay. So they're asking me where the focus points are, where the foci are. Where are the foci on an ellipse? They're always on the widest direction, aren't they? If the ellipse is wider, then they're right, left. If the ellipse is taller than it is wide, then they're up, down. They're on the major axis. So they're going to be sideways. So the focus is going to be like over here and over here or something, you know, from the center. Because this ellipse is wider than it is tall. If the ellipse was taller, then the focus points would be up and down, wouldn't they? The focus points are always on the longest direction. Okay, so they're right and left. Well, how far? Well, you know the focus equation. Got to use the focus equation. A squared, B squared, C squared. Now, is it plus or is it minus in this focus equation? Yeah, whatever's in the main equation, it's opposite in the focus equation, remember? There's plus in the main for ellipse, then there's minus in the focus. So it's always opposite. Now, when you have two things subtracted, the order matters. You got to put the bigger one first, don't you? So that would be the 6 squared, and the other one is the 3 squared. C squared, so that's 36 minus 9 is C squared. What's that? 27. C squared is 27. Good to there. And then we root it. Root it. That turns out to be 3 root 3. You guys okay with that? Square root of 27, you know, 3 times 9. And that's 3 times 3. Remember, 2 3's in, sends 1 3 out. The other one stays in. Remember how you do roots from algebra? So 3 root 3. So what? So 3. So that means from the center, it's add 3 root 3 to the right, and it's subtract 3 root 3 to the left from the -1. This is back 1 up 2. From the x-coordinate of the center. Right? So it's -1 plus or minus 3 root 3, comma 2. That's where the two foci points are. Is that too quick? You tracking with me? I took the center, -1, 2, And to the x coordinate, because right, left for the foci, I added and subtracted 3 root 3. So negative 1 plus and minus 3 root 3, comma 2. Well, it's not a, because they're all comma negative 1. No way. It's not b. Now, you might look at b and think that's it, but look, they're missing the 1. See how b is missing the 1? They just have the 3 root 3, but they don't have the 1. You got to have negative 1 plus or minus 3 root 3. It's not b. How about c? Yeah, negative 1 plus 3 root 3, negative 1 minus 3 root 3, comma 2. Yeah, c's looking good. Last thing, vertices. You got to check the vertices. This one, sure enough, is over 5, and this one looks like it is back 7. Yeah, c's right. C's got everything. Yep. We good there? All right, I better move along. So what do we always have to get? We always have to get a 1 on the right side, right? So I'm going to divide through by 144. Now, that's a little challenging without a calculator. That's probably the biggest numbers we've had without a calculator. The right side is 1. 16 into 144. You can just long divide. Remember long division? So you can just go 16 into 144. You'll find out that it's 9 times. 54, 144. It's 9 times 16 is 144. So you go, oh, this goes in there 9 times. So it's x plus 1 squared over 9. You do have to be able to do this without a calculator. 9 into 144, 16 times. This is as messy as it's going to get. I'm not going to have a lot of mess. You know, I don't want to waste your time with a lot of number crunching without a calculator. But I think that's reasonable. So 3 squared and 4 squared. Remember, always rewrite them as squares. Makes it easier. Okay, so what's the center then of that shape?
Negative 1, positive 1.
Yeah. Opposite, opposite. So negative 1, positive 1. So that means draw your picture. Back 1, up 1 right here. There's the center. And it goes right, left, 3. 1, 2, 3 to the right. 1, 2, 3 to the left. And it goes up 4, down 4. 1, 2, 3, 4. It's a little taller. 2, 3, 4 than it is wide, a little bit. So it looks sort of like that. Which one looks like that? D. There's not even a none of the above on that, is there? Because I don't want you to get fooled on graph pictures. I don't want you to think I'm doing some trickery or something. It's D. Good. We'll move on. Around. I'll jump to 16 here. Let's do 16. So graphing calculator, you let y1 be the left side, let y2 be the right side, graph them, but when you graph them, you've got to find the intersection on your calculator, and you will have to adjust your window a little bit because it's hard to see the intersection on the normal window. You have to adjust your window to go like x min max, y min max, I don't know, something like negative 2 to positive 2, negative 2 to positive 2, we'll get it. You know, something like that. Adjust the window. Do the intersection routine on your calculator, you know, and find that. And it's none of the above. It's kind of disturbing. It's a negative 1.14 or something. Is that what it was? Is that right? Do you remember? Something like that? Yeah, I think it's negative 1.14. So, is that what it is? You got it? Negative 1.14? Good, okay. Yeah, so it's none of the above. So, come see me. I'd be glad to help out if you're a little rusty on how that works. Quick, if you remember, I mean. Just 2 logs on your calculator. Right, remember when you have like log base 2.8, 25, you let the high go high and the low, what am I doing? The low go low, and just hit the buttons on your calculator. Right, we good on that? Just hit the buttons. So I'm going to move on. These are the oldest. It's been longer since we've done these. We're fresh on the other side. All right, blah, blah, blah. This is clearly exponential growth and decay, right? Whenever you have populations growing and shrinking, right, that's always PERT. We're always going to use the PERT formula. Remember that? These last 3, it's the same thing as continually compounded interest, isn't it? Because that's how populations grow, is continually compounding. Okay, so what does it say? There were 80 of these things in 2009. That's like the principal investment. That's the original amount. Does that make sense? The amount put in the bank at first, the amount put in the forest at first. In 2012, how many years later is that? 3. When time is 3, you see that? That's T 3 years later. They tagged 160. The amount was 160. 3 years, bless you. 3 years later. Do you see what just happened there? 160 was the amount 3 years later. So when time is 3, the amount's 160. Remember how these always work? The first phase, there's in 2 phases, you have to find R, and then the second phase, you finish the problem, remember? They're always like 2. They're like 2 problems in 1. So first, I just have to do a bunch of work. Don't worry right now about the 8 years. We'll get to that after I do a bunch of work and find R. Remember, first solve for R. So that means divide by 80. So that's 2 equals e to the r times 3. And now what do you do to solve for R, which is up in the power zone? Ln. Ln of both sides, right? When the letter climbs into power, when Hitler and Stalin climb into power, you got to do Ln, bring it down. So Ln 2 is R times 3 Ln e, and Ln e is 1. So Ln 2 is R times 3. So divide by 3. Divide by 3. R is Ln 2 over 3. So we've got R. So now restart. Restart and use the PERT formula again. But now we know what R is. Now we know. And the initial amount is still 80. That doesn't change, right? That's the initial amount. Now the R is Ln 2 over 3 to the t. Does that make sense? So remember how these always work? So you do the first phase, get your hands on R, restart with the PERT formula, put in your R. Now remember what happens here to make it easy? The E and the Ln cancel, and the 2 drops down, but the t over 3 stays in the power, right? A lot of students get confused by that maneuver. Is that okay? Do you see that? Why does the 3 and the t stay out here? Because they're not in the toaster. Because they're not in the Ln. It's not Ln of 2/3. The 3's not plugged into the toaster. The 3's underneath the toaster. So when the toaster goes away, right? If you could go away, crunch your toaster with some kind of magic hands and make it, the toast just fall down on the counter, right? It wouldn't make your blender fall down on the counter, right? It's whatever's in the toaster. So that's why the 2 drops down. And the t over 3, right? T over 3, this is t over 1, so it's t over 3 now. Stays up there in the power, right? You okay with that maneuver? Okay. Now, 8 years. 8 years later, so that means let t be 8. Huh. Just plug in t as 8. So 80 times 2 to the 8 over 3. Hit the buttons on your calculator to get the answer. What is the answer? I don't even know what number that is. 25. The answer was, oh, E? How disturbing. So somebody get the answer on that? What is the answer? Would you guys mind shutting that door with me? Thanks. What is the answer real quick? What is it? 508? Something like around 508? Okay. Yeah, I just want to make sure you guys have something to look at.
507.968.
507.9, whatever, blah, blah. 508. Basically 508. Thank you. Yeah, and that's not there, so none of the above. Just want to make sure you can get it on your calculator for later. Is that good there? So exponential growth decay, PERT formula, 2 problems in 1. First, do all the work, get your hands on R, start PERT again, finish it up. Okay, right, yeah. So number 16, fossilized leaves contains 13% of its normal COM14. 5600 is the half-life. Remember I gave you a little shortcut for half-life problems? What was that? It was A equals, I don't know, P 0.5 to the T over half-life, right? Is that right? Is that what it was?
No, R equals 0.5.
Did I? R equals ln 0.5 over the half-life. R equals, yeah, okay, yeah. So yeah, I gave you a shortcut on a half-life. I mean, you can do it a long way. It'll work the same. But I gave you a shortcut on any half-life problem. R is going to be ln 0.5 over the half-life. So that means R is going to be ln 0.5 over, what's the half-life? 5,600. So that's R. I gave you a shortcut to jump right to the R. Not you can skip phase 1 when they're giving you a half-life. It's ln 0.5, that's the half, over the half-life 5,600. So that means you do the PERT. Go on, now I'm doing phase 2. I just go right on to phase 2, having already obtained R. So that's going to be P e to the R ln 0.5 over 5,600 T. Same thing, E and ln cancel. The toaster goes away, toast falls to the ground, to the counter, and that's the 0.5. But the T over 5,600 stays because it was never in the toaster. So we get to there? And really, if you want to just jump right to here, this is always, maybe that's even a better place to go. Half-life problems will always end up there. They'll always end up 0.5 is the base, T over 5,600. Okay, now, can we finish the problem? 13% of it is left. What do I do with that? 13% of it is left.
A.
The amount is 0.13. Right, 13%? Is that good? Right there? That's almost good. But not quite good, and a lot of people get messed up because they do just that. And then they get stuck so close. So much want to help with this. Now's my last chance to help, probably for most of you. What's wrong with that?
There's no P on the other side of it.
Yeah, if I just said, hey guys, 13%, what would you say to me? Just real life. You'd go, 13% of what, Mr. Heron? Right? There's no such thing as 13% alone, huh? It's 13% of something. So there's no such thing as 0.13 alone. It's 0.13 of P, right? The amount is 13% of the original. Time, of means times, so times the original principal, right? Does that make sense? All right. So the reason that becomes a big deal is because then you can get rid of the P. Whereas if it's the students in the past have got messed up because it's only on one side, then they're stuck, they don't know what to do. Well, it's supposed to be on both sides, right? And then it drops out, so it's totally gone. So 0.13 is 0.5 to the T over 5,600. What do you do now to solve for T? ln, I just go dot, 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 power comes down, blah, blah, blah. Right? That good? To there? Right? Bring the whole power down, and just like the last one.